So we're doing, of course, phase 1, lecture 3. So we started looking last time at the issue that I'm not interested in necessarily what is in a set, not making a list of all the elements, but I'm more interested in how many are there. And we looked at Venn diagrams and sets, and that's one type of question we want to be able to do. Now we're moving on to counting how many ways things can happen. So I'm looking at an experiment, I'm looking at an outcome of the experiment, I'm looking at an event as some outcomes that are more interesting than others that I'm interested in, and I want to count how many ways something can happen. So let's use example 1, sort of a little silly example, just sort of to lead into the concept that we need. Example 1. A husband, wife, and their pet attend an international conference. Now I know what you're asking. What conference does a pet go to? Could be a child, it doesn't really matter. It's an old question. Delegates from England, Germany, France, and Spain attend the conference as such a trio. Husband, wife, pet. How many, let's say, individuals are there at the conference? Now I can make a little table. Let's put the countries at the top. Let's say here England, Germany, France, Spain, and the type of individual, husband, wife, pet. And let's make a little dot. There's a husband, wife, and pet coming from England, from Germany, from France, and from Spain. Now, because my numbers are so small, I have 3 types of individuals, I have 4 different countries. I can easily see that there are 12 different individuals. 12 different, let's say, individuals. That's reasonably easy. But I'm trying to use this example so that when things get more complicated, when the numbers are bigger, I want to develop a way of thinking that can be applied to something more general and something more complicated. Even though in this case it's overkill because clearly there are only 12 individuals, I want to use this to come up with something more sophisticated, I guess is the word. So instead of thinking of people/pets, I'm gonna think, well, let's pretend everyone has a name tag. Now how you attach the name tag to a pet is totally up to you. I'm just sort of pretending. Every individual has a name tag. And the name tag consists of 2 things, 2 entries. One, the type of individual. The other one, the country. So let's say here the type and the country. Just check something. 1 second. I wonder if the camera is being cut off. No, it's okay. I'm just checking, sorry. Never mind. Moving on. Okay. So let's pretend every individual has a name tag, and on the name tag is the type of person and the country that they're from. So there are 2 aspects to the individual. If I just know the person is a husband, that doesn't specify a person exactly.
In the the question is, does it, like delegates from England, Germany, France, and Spain also attend?
We can scratch out the also.
Okay.
I'm focusing on these people. Fair enough. That also can be scratched out. These are the delegates that attend the conference. I'm not interested in anyone else. So everyone has a name tag, and just knowing one entry in the name tag doesn't specify an individual exactly. I need to know both. And if I do have a specific name tag, that corresponds to a specific individual. So let's say each name tag corresponds to a specific individual. Now, my goal here is to come up with a way to count the individuals. But instead of counting the individuals, I can count the name tags. Let's say here the number of individuals equals the number of name tags. So instead of, I can objectify these people and just look at a name tag instead. There's a correspondence between the actual individual and the name tag. So let's count the name tags instead. And instead of counting the name tags, I can think of it as counting how many ways can I make a name tag under this restriction. What is my restriction, or how many different types can there be on a name tag? Three different types. So I have three choices to make a name tag. For the first entry, not the whole name tag. Three choices to make the first entry, or fill in the first entry in the name tag. Could be husband, wife, or pet. Three choices. That's not the whole name tag. I have to follow that by filling in the country entry. How many choices do I have for the country? I have 4 choices for the country. England, Germany, France, and Spain. And if I filled in the type, if I filled in the country, then I completed my name tag. And I'm interested in how many different ways can I make a name tag. That's going to be the same as the number of name tags. That's the same as the number of individuals I'm actually interested in. So we know it's 12. But if I look at breaking it up in this way, I'll do it already. I can get 12 by noting it's 3 times 4. And this 3 times 4 comes from this 3 and this 4. This 3 and this 4. So this leads me to say that the number of individuals is the same as the number of ways I can make their name tag, their label. How many ways can I make this label? 3 ways for the first entry, 4 ways for the second. So for every one of these first entries, there are 4 choices. So it's 3 times 4. Everyone happy with the idea of making a name tag instead of counting individuals? It's the same thing. I'm looking for the number. I'm just sort of conceptualizing it to counting how many ways can I make a label. Every individual has a label. So this leads me to the basic principle of counting. So I'm going to write this out so that we have it in our notes, but it does get a little wordy. really just repeating what we did with these name tags. Let's put squiggly lines under it. Okay. So, in the example, my experiment was making a name tag, making a label for the individuals, and I wanted to count how many different ways can I make such a label. So, if I have an experiment, and it can be completed let's say in steps. Making a name tag, I completed it in 2 steps. 1 step for the entry, next step for the country. Let's say here, I can do step 1 in, let's say, X possible ways. I don't know how many. In our example, it was 3. But it could be anything. There could be many different types of individuals. So it could be any number. Step 1 can be completed in X possible ways. Step 2 can be completed in, let's say, Y possible ways, another number. In our example, it was a 4. So my experiment is broken up into 2 steps. Step 1 can be completed in a certain number of ways. Step 1 in our example was the type in my name tag, and I can do that in 3 possible ways. Step 2 can be completed in a different number of possible ways. It's something else, choosing the country. That was completed in 4 different ways, 4 different countries I can put in. So it could be a different number. So if I have an experiment that can be completed in steps, then the total number of ways to complete the experiment as a whole is X times 1. I multiply these 2 together. Let's write this X a little differently so it doesn't look like a time symbol. X times 1. It's just generalizing the statement that we saw happening in my specific example. Now, nothing says that I have to have only 2 steps. This generalizes to any number of steps. If I can break up my experiment in successive steps, 1 step followed by the next, completing my experiment, like choosing the type of the individual, then choosing the country. If I have other things I have to choose to make a more complicated name tag, I still do 1 at a time. Let's suppose I have an experiment. I won't write out the whole sentence. It's just generalizing this idea to more steps. Let's suppose I have an experiment with, let's say, R successive steps. Let's say step 1, followed by step 2, followed by all the steps 1 at a time, all the way to R steps. Let's suppose step 1 can be completed in X1 different ways. X2 can be completed in X with a little subscript 2 because the number could be different. So, different number for step 2 potentially, all the way to step R. I'm just generalizing it, so it's going to be a little bit messy when it's more general. Every step has a different number of choices, a different number of ways, potentially, that it can be completed. And my whole experiment consists of all these steps in sequence before I'm done. Then the total number of ways to do the whole experiment is the product of these numbers. Now, when we get to something more specific, examples, then it'll become more clear. But we try and see the idea and how the name tag example was generalized to this. Any questions on what I'm trying to say here?
Those are all times between, right?
These are all times, yes. We'll put a little time symbol, doesn't matter. It was 3 times 4. If I have 2 steps, x times y. But I can have many steps, as many as I need to complete my experiment, depending on what the experiment is. Then I look at each step individually. So it's a way to break down the complicated experiment into small, manageable steps. Looking at each step, and then to figure out how many ways can I complete the whole experiment, I just multiply those guys together. So it'll be better as soon as we look at more examples. So let's just do that. So this whole phase 1, yeah, we had to talk about sets and so on to make things a little bit easier now and then. But the whole idea is, in this setting of counting, to see some examples and problems where I have a systematic, structured way to work through them, to think. And it's that way of thinking that we're trying to practice. Let's do example number 2. How many different 7-place license plates are possible if the first 3 places are to be occupied by letters and the final 4 by numbers? So let me make my license plate positions here. 1, 2, 3, 4, 5, 6, 7. So I'm trying to count the number of license plates. So let me write number of license plates. That's what the question is asking. But that's the same as the number of ways to make a license plate. There's a subtle difference between these. Here I'm counting license plates. Here I'm counting how many ways can I make a license plate. Now that's the experiment that I want to think of. These two are the same. Now my experiment is making a license plate. And I want to break that up into small, manageable steps. Yes?
Can the numbers and letters be repeated differently?
We have to look at the questions just as it is. So if they don't say anything specific, I'm not assuming anything. They say how many different 7-place license plates are possible, and my restriction is the first 3 places are letters, the final 4 places are numbers. That's all they're giving. So what do we think? Can I repeat a letter or not? They don't say I can't, so I have to cover that possibility. The letters can repeat. So what are the steps in this experiment? Step 1 is just filling in the first place in the license plate, followed by step 2, filling in the second one, followed by step 3, 4, 5, 6, and 7, and then I've completed my experiment. So it's important that we're aware of what are we doing. I'm making a license plate. That is my experiment. How do I break that up into little steps? My steps are just one position at a time, filling in one position at a time. How many choices do I have to fill in the first position? 3. 3 or 26? 26 choices. Any letter. So my way of doing it is just writing it underneath with a little arrow. How many ways can I choose something for the second position? 26, you say confidently. I can have any of the letters. Jen, this one? 26. This one?
10.
Now I need a number. Any one of the 10 numbers.
0. 10.
All right, well, let's just go down and make sure it's 10.
You got 0 as well.
0 is also fine. They don't say 0 isn't fine. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Not 10. Up to 9. 10 total. Does that make sense? Okay. 0, 1 through 9. It's 10 numbers. And I can repeat the numbers. I'm forgetting what I actually might know about license split, because it might not be a realistic license split, it's just a pretend license. So, the basic principle of counting then tells me that if I have an experiment and I've completed it by doing one step followed by the next, followed by the next until I'm done, each step can be completed in a certain number of ways. How many ways can I do the whole experiment? I just multiply all these numbers together. Now you can put this, you can put that into the calculator, but I really don't care. I'm interested in the method. How do you construct? How do you get your final answer? Not what big number is at the end. That means nothing. This means much more. It shows me how I get to my answer. Any questions on how we use the basic principle of counting? So we break it up into little pieces, and then we put it together at the end. And the basic principle of counting tells me how to put it together. Let's do more examples. That's really the secret here. Just do examples and get used to the idea. Number 3. How many of these license plates would be possible if repetition among the letters or numbers was not allowed? No repetition. So it's the same thing, same experiment, but a different restriction. Now I'm more restricted. I can't repeat any letters. 1, 2, 3, or numbers. 4, 5, 6, 7. So my experiment is the same, so it makes it easier. How many ways can I do step 1?
26.
26, any letter is fine. Then let me write some choices to remind myself what am I doing here. Now, whatever was selected here, I can't choose that again. So my number of choices goes down by 1. And the next one?
24.
And then this one?
10.
10. Now this is where numbers go here, right? This is letters. So I don't care what letters I put here, and it's got nothing to do with this next position. This has to be a number, it could be any number, so I have 10 choices. And then, can't repeat, then I have 2 numbers here already, so I only have 8 choices left, and only 7 choices left. So because I can't repeat, the choices go down a little bit, the number of choices go down. So the total number of ways to make a license plate, I'll write it out because we're still starting with this. Is 26 times 25 times 24 times 10 times 9 times 8 times 7. And you can leave it like that. I really have no interest in what the whole big final number is. Our purpose here is to practice a way of thinking, a systematic way of thinking, where I break it up into little pieces and think my way through the question. Not in calculator use, I really don't care. Any questions on the basic principle of counting? All right. Let's keep going with our examples. Each example shows me something. This was sort of the basic introduction example. Let's look at number 4. 12 teachers are to be assigned to 3 schools. How many assignments are possible if there are no other restrictions? Any teacher can go to any school. Any school can receive any number of teachers. So let me make a little diagram here. 12 teachers, and I want to assign them to 3 schools. So it's important to understand what it means when there's no other restriction. No other restriction. Let's number these schools, school 1, 2, and 3. Can school 1 get all the teachers, school 2 gets nothing, and school 3 gets nothing? Anything is possible. All the teachers can go to one school, or they can be spread out, or 2 schools can get most of the teachers. Anything is possible. So, I really have only 2 options here. Option 1 is, let me list the schools. School 1, school 2, school 3, and go through them one by one and see what are my choices and then put them together at the end. Or, I can list the teachers. Teacher 1, teacher 2, teacher 3, all the way to teacher 12. And go through the teachers and see. Those are really my 2 choices. I can't really do much else at this point. Let's do this one. Let's just look at this and see how would I attempt something like this. So now I'm listing the schools. What's my experiment? My experiment is assigning the teachers, counting how many ways can I do that systematically. Now if this is my strategy by listing the schools, what is that first step? What is that? What am I doing? What am I trying to do in that first step? No, not silence.
With any possibilities.
I'm looking for all the possibilities, all the different ways I can assign teachers to school 1. But the problem is that there's no restriction other than that. Other than 12 and 3, there's no restriction. So how easy does it feel to do that? Can I get a number there? What is the number?
12.
13.
I heard 12. I heard 13. Why am I not comfortable with that first step? I have to look at all the possibilities. One possibility, well, part of those possibilities is where only one teacher goes to school 1. Then it could be any one of the 12. So let's say here, this is when exactly one teacher goes to school 1. But there are many other possibilities. It could be any pair of teachers. What if what if school 1 gets exactly 2 teachers? How do I know which 2 of the 12? There are many different pairs of teachers I can select. What about, so let's write it here. What happens when I have exactly 2 teachers going to school 1? What then? What's this number? I have no idea. I can probably make a list of all the possible pairs, and then, but I want to avoid any list because that's going to be too much work. And there are more possibilities. What if 3 teachers go to school 1? How many ways can I select 3 of the 12? Many, many ways. What about 4 teachers? 5, 6, 7, all the way to 12. And when you think of it that way, very quickly, it doesn't seem like something I can do in any realistic time. When I have to make some lists and try and get those numbers together. It doesn't seem simple. So at the very least, all I want us to agree on is that it's not that simple to get that number. And with what we have, it's not realistic to get this number. If I have a couple of hours, maybe I can find it, but that's not the point. And even if I do manage to spend the hours making my lists and getting a number here, what do I do with the next step? The number of options I have available for school 2 depends on what happened to school 1. If, let's say, 4 teachers went to school 1, that affects the choices for school 2. If only 1 teacher went to school 1, then I have more choices for school 2. So it's sort of it sort of flows over to school 2, creating more problems there. And I don't even know what happened to school 3. So quickly it seems like this is just, doesn't seem like it's the way to go. So my only other option is this guy. So let's see if I have a similar problem here. Now I'm going to break up my experiment. My experiment is clear. I have to assign all these teachers and count how many ways can I do that. If I break up into these steps, step 1 is just assigning teacher 1 to a school. How many choices do I have to assign teacher 1 to a school? 3 or 4?
4.
Everyone has to go to a school.
3.
Teacher 1 has 1 of 3 possibilities. They have to go to a school. Not working is not an option. Now when I go to school, teacher number 2, and I look at all possibilities, teacher 2 doesn't care what happens to teacher 1. Teacher 2 has 3 choices. Regardless of what teacher 1 did, teacher 2 can go to any of the 3 schools. What about teacher 3? Still 3. Just 2. Okay. Good one. Every time, because there's no other restriction, they have 3 choices every time. So it seems like I avoided what the problem was here. It's important that I see this problem because if I come across this question, how do I know which one to list? I tried this one because it was shorter, but it created a lot of problems. And it was because they depend on each other. Here, the teachers and their choices, they don't depend on one another. They're always going to be 3. So I can say, I can break up my experiment in any steps that I want as long as completing the experiment can be done by completing step 1, followed by step 2, followed by step 3, all the way. Both of these were valid ways to break it up into steps, but when it gets down to counting the steps, this first one didn't quite work out easily, but this one did. So the number of, let's say here, assignments is 3 times 3 times 3 times 3, 12 times, so 3 to the power of 12. So a lot of things happen in this question that I should be aware of. I should be able to see how difficult something like this is. Can I do it? And I have to think carefully. It's not just 13 for that first position because there are no other restrictions, so anything can happen. So I have to see all the possibilities that can happen and then realize that that's not. Doesn't seem practical, so let's try something else. What else can I do? Oh, list the teachers instead. Do I have the same problem? No, it seems like their choices, it's always 3 all the way. I can do it like that. Any questions on this? Maybe we're shocked a little bit, not sure what is happening. It's okay, it'll wear off. It'll wear off. Right now, what I'm trying to focus on is thinking about these things carefully. Breaking it up into little steps. Being aware of what my experiment is. What am I trying to count? What am I trying to do? Break it up into little steps, and then put it all together.